In the previous time we talked about the standing waves. If you look here, okay, standing waves, guys, consist of progressive waves. These progressive waves can as outgoing from a generator here or from the source, and it will be reflected back from this fixed point. As a result of this, or as a result of this interference between the outgoing waves and reflected waves, there are certain points where they are called nodes, where the outgoing waves and reflected waves are interfering destructively, crest with a trough like this. At certain positions, guys, which are called antinodes, the outgoing waves and the reflected waves are or interfere constructively, crest with a crest. So I will observe a pattern here for the standing waves. This pattern consists, or any standing waves consist of series of antinodes and nodes. Okay, and as what we mentioned before, this our standing waves has a pattern like this, which are called harmonic. These harmonics started, or we can call them first, second, third, and so on. They call it harmonics because there's a harmony here, there's a pattern. This pattern, if I consider the first frequency where the standing waves are formed, it's called fundamental frequency. The second harmonic, also the standing wave is formed, but it has different shape like this. This takes place if the frequency is doubled, the fundamental. Third harmonic, same thing, different shape, but it takes place, or I can see it if the frequency is tripled, and so on. Okay, guys, so this is first harmonic, second harmonic, third, and so on. So there is a pattern here. This is the first point. The second point, guys, any frequency beyond the first and second, or beyond the second and the third, or any frequency that is not, just a second. Okay. Any frequency, guys, between first to second, or between second to third. Okay, at these frequencies we will not observe any standing wave pattern, and I will observe disturbance, right, but I will not observe standing wave. So the standing waves, guys, are taking place at specific frequencies. Also here, if you remember, we discussed the difference between nodes and antinodes. Antinodes, guys, it's a result of constructive interference between outgoing waves and reflected waves. Nodes, it's a result of destructive interference between outgoing waves and reflected waves. Now, this is a very important question. What is the distance between two successive nodes? Guys, between two successive nodes, like this is the node, this is the node, this distance is half lambda. Okay? Between two successive antinodes, This is antinode and this is antidode. Also, this is half lambda. Okay, guys. What is the distance between nodes and antinodes? He quarter lambda. Will be a quarter lambda. Okay. Now there's an experiment for investigating the standing waves. You know this. This is the speed of the waves, which is equivalent to frequency times wavelength. Also, this is will be given to you. The speed of the wave is equivalent to square root of tension over mu, where mu it's the mass of the string divided by the length, divided by its what length. It's called mass per unit length. T is the tension. Why? Because guys, as long as the string is taut between two fixed points, we can or this string accepting standing waves. Otherwise, no, I will not observe any standing wave pattern. Any standing wave pattern. Okay. So if I substitute here instead of velocity, you know the frequency is what? Velocity over lambda. If you substitute instead of velocity this value, okay, I will get this. Here guys, attention, or to make this experiment, I will show you this. We have to bring two blocks like this. We have to tightly place the string between these two blocks. And here guys, we will have what pulley, وعند البولي هون في عندنا weights. Guys, these weights that would be added here exert what? A tension on the string. As a result of that, the string becomes taut, so the standing waves can take place or can be observed if I disturb this string. Now, if you remember guys, in the previous part, كان إنه lambda رح تكون 2L over N. Right? Lambda will be 2L over N. Because here, guys, there is a pattern. There is what? A pattern. Where N is the order of harmonic. First, second, third, and so on. So this is first harmonic as what you see. This is second harmonic. This is third harmonic, and so on. So if I substitute here instead of lambda, and F equals, if I substitute instead of lambda 2L over N, as what we discussed in the previous time, I will get this relationship. Guys, in this way, I can predict or I can find the frequency of any harmonic. It depends on length, tension, and what? Mass. Length, tension, and mass. Okay, the frequency of any harmonic depends on these three factors. Okay guys, here we will discuss now the phase or time يعني the shape observed of the wave versus the time or the phase. We can consider it as a phase. Like guys, here I have to focus. Sorry, I have to compare here between two things. Guys, this is a very important thing because we have to distinguish between the progressive waves and the standing waves. Here, guys, this is a standing wave, right? This is a standing wave. Pay attention now. Guys, if I consider two different moments here, okay, I will take here screenshots for two different moments. Pay attention, guys. Now I'm taking two screenshots for two different moments of the progressive wave, and I will compare it with two screenshots to a standing wave at different moments. Okay, guys, this is the first moment. مرة تانية. And I did here two screenshots at different moments for progressive waves, right? This is for what? Progressive waves. Okay, this is the first moment. You can copy it, paste it here in order to compare. طلع معي على هدول المومنتس. Guys, look to the disturbance. Okay, look to this disturbance, guys. This is before, right? Or the moment before, or this is the moment after, or no matter which is before, which is after. Let's consider this. Okay. Here the wave, look to this peak, or look to this disturbance. It was in this position, right? It was approximately where? In this position. Then it moves where? To this position. Disturbance, I meant. The particle stays at this in its point. The peak here, it's shifted my time to this position, right? Is that clear, guys? So the peak was here, then it's shifted here. So with the time, the disturbance moves along this in this way. This is in progressive waves. Clear? Okay. So I can say roughly speaking that the peak is shifted horizontally, or any particle after certain time, right? It will be shifted where? Horizontally. Okay, clear, guys? Or a disturbance is shifted horizontally with time. Any question about that? Right. If I go to the standing waves, can anyone tell me, roughly speaking, after certain time, let's say quarter period or half period, let's say I have, this is the shape of the wave at first moment. After second moment, this peak is shifted where? Downwards. Right? Because in motion of standing waves, up, zero, down, and so on, it oscillates up and down only. This is why it's called standing waves, because the disturbance does not move from one point where to another. It just oscillates in its position. The standing wave first period, let's say this is the first moment, this is the resultant wave. Let's consider first of all بس the green one. After quarter cycle, it returns to the position here, يعني it shifted down, let's say. It becomes at the equilibrium position. After another quarter period, it will be shifted back here. Look to the green one only. Look to the green one. After quarter period, again, it returns back to the equilibrium position. Then it returns back after one period to its what? To its initial position. So here, guys, with the time, it's not like or it's unlike the progressive wave. The disturbance, roughly speaking, is not shifted horizontally. It's shifted vertically, if I can say that. Clear? In other words, guys, I can write like this. No, let's say starting with maximum, after quarter period 0, after quarter period it becomes minimum, then 0, after quarter period it returns again maximum, then 0, and so on. This is the pattern for standing waves. This is after quarter period. After quarter period. Okay? Let me show you how you will be asked about the phase difference in standing waves. Here we have V, W, X, Y, Z, these points. Here consider Y, Z, V. Let's consider it as E, D, F, G, no matter. Guys, first of all, this is a standing wave. Okay, it might be looked as progressive wave, but it's mentioned as standing waves. These points are called nodes, right? These points are called what? Nodes. Now, what we are asked to find is state the phase difference between W and Y. Guys, to find the phase difference between any 2 points, to find the phase difference, find the phase difference between any 2 points. We will use this formula, guys. M pi. What is M? M, it's the number of nodes between these 2 points. Pay attention. Number of nodes between these 2 points. If I consider W and Y, here we have one node between them. So M equals 1. So if I want to find this phase difference, it's 1 pi, which is pi rad, or 180 degree. If I consider Y and Z, guys, Y and Z, no nodes between them, صح? So M equals 0. So the phase difference between them is 0. As what I mentioned before, guys, between any 2 successive nodes, any 2 successive what? Nodes, or any 2 points between any 2 successive nodes, they will oscillate in phase. And these particles, either they are oscillating downward together or oscillating upward moving upward together or moving downward together. Is that clear? If I consider another points, guys, if I consider W and E. If I want to find the phase difference between W and E. This is W, this is E. How many nodes between them? Yes, exactly, 2 pi.
2 pi.
لأن هون عندنا طلع معي. How many nodes here? 1, 2. We have 2 nodes here. So if I consider W and E, it's 2 pi. So they are in phase, by the way. They are what? In phase. If I consider W and D, the number of nodes between them is 2, so it's 2 pi rad. Yes. Guys, if I consider F and W, it's 3 pi, guys. M
3 pi.
equal 3. This is W, guys. Pay attention. Hi. This is W again, and this is what? F. If I consider F and W, here we have node, 2 nodes, 3 nodes. So the phase difference between them is 3 pi, which is antiphase. Guys, again, look here, guys. The possible phase difference or the possible phase differences between any 2 points, either phase, in phase, or anti-phase ترى ما في يعني. It's unlike progressive waves. The progressive waves we can find the in phase, will anti-phase, will out of phase. Here, either the points are oscillating in phase or anti-phase. There are no any other choice. Clear? إنه in standing waves either the particles oscillate in phase or anti-phase. And you don't have any other thing يعني either 0 or 360 or whatever, and these are the possible phases between all the particles along the standing waves. This is, guys, if we are asked to find the phase difference between 2 points along the standing wave. But just to compare between standing wave and progressive waves, if we are asked to find a phase difference between 2 points at the progressive waves like this, تتذكروا شو كنا نعمل؟ طاهر, how can we find Muhammad? How can we find the phase difference between 2 points along progressive waves? Shall I repeat? ايش كنا نحط؟ كنا first of all we have to find the shift in position, right, divided by the wavelength multiplied by what? 360, if you remember, or 2 pi.
360.
We have to do something like this. Is that clear, guys? Here I have, let's say, مثلا, if I want to consider this point with this point, I have to find first of all the shift here, x. Then I have to divide this shift by the wavelength multiplied by 360. This is how can we find the phase difference where in progressive waves. In standing waves, something easier, just a second, something easier. I have to count how many points between, how many nodes between these 2 points and multiply it by pi. Yes, I mentioned now before. You know, the 2 possible phase differences هم either in phase or antiphase. Okay? Antiphase. Now also, guys, we may have a question like this. Draw the pattern of standing waves after T over 8. Before considering T over 8, let me consider this. Yani we are asked to draw the wave here after quarter period. After quarter period, guys, if I take a screenshot of the wave, it will be at the equilibrium position. It will be at equilibrium what? Position. You got my point? Is that clear? And guys, and I have waves or string that oscillating up and down, right? I have now a string that oscillates up and down. At certain moment, if I take a screenshot after quarter period, right, I will get what? A wave or the string at its equilibrium position. Is that clear? After half period, if I take a screenshot, I will see it like this. Okay, guys? Please, if you have a question, please ask me, guys. After half period, I will, if I take screenshot of the standing wave after half a period, I will see this screen, I will see the string like this. After 3 quarters, it will return again to the equilibrium position. Okay, guys, after t over 8, it will be in this position. And تقريبا the middle of this point. Okay, you got my point? Because, guys, the wave is moving now at this moment downward. Then it reaches the equilibrium position. Then it reaches the minimum possible value after quarter cycle. Then it returns back, and it was here, right? Then it will return back to its equilibrium position again. After 5t over 8, after what? 5t over 8, guys, pay attention now. This is 0, right? At this moment, it's 0. At this moment, it's 1/8. At this moment, it's what? Quarter cycle or 2/8. This moment, 3/8. 3/8. At this moment, 4/8, which is half period, right? Which is half period. Here, it's the way or the string is moving down. After half a period, the wave returns back again. So here, this is a 5t over 8. And you have to follow what? The pattern here. You have to follow the pattern. Again, guys, this is after half period, which is 4t over 8. Then this is at 5t over 8. This is what? 6t over 8. This is at 7t over 8. So at 7t over 8, it will be here. The position of the string this way. So, guys, I have to follow this. I have to follow this pattern, like what I wrote here. No, first of all, if it starts with maximum position, after quarter period it will be 0. After quarter period it will be the string will be at its minimum position, right? Then 0, then maximum, then 0. And here we have to consider 1 point. Here we have to consider 1 point. If I consider 1 point and take screenshots at different moments or after quarter period for this point, I will observe this pattern. This will help you also in in drawing the wave after certain period. The concept of the phase difference, okay? The concept of what? Of the phase difference. Guys, in order to consider this, I have to consider this pattern. Consider any point. The observation, guys, if I consider only single point or single oscillating point along the string, and I want to observe displacement تبعتها. Displacement might be maximum, but then 0, minimum, 0, maximum, 0, and so on. I will observe this. Yani this particle will oscillate up and down or right and left, no matter what is it. So at its maximum displacement first, after quarter cycle, it returns to equilibrium position 0. Then after quarter cycle, it becomes minimum. Then after quarter cycle, it becomes 0, and so on, in this way. Okay? Here also another type of question that you might be asked about it. We have to draw the wave pattern after certain period of time, or after, sorry, certain time. Like draw the pattern of the standing wave after t over 8, t over 4, t whatever. And as what I mentioned before, guys, I have to consider one point. Let me start with this one. This is, if I start with this one, so I started here with maximum point, right? After quarter cycle, guys, this particle becomes here. So I have to draw a line. Clear? Is this technique clear? Guys, consider one point. After quarter cycle, as what I mentioned before, the maximum position of the particle becomes 0. So this, if I take, guys, a screenshot at quarter period, right? I will observe that the standing wave or the string, this straight. Okay? If I consider t over 2, guys, امشوا معي بالsequence. يعني هلا we have to follow this sequence. This is the maximum point that we consider. After quarter cycle, امشوا معي. Listen, guys, to me. Pay attention. After quarter cycle, it becomes here. After another quarter cycle, it becomes here. Okay? So I will draw a mirror reflection of this way. هلا if I want to, if we are asked to draw it after 3 quarters, please follow me, please, guys. طلعوا معي شوي. هاي 1 quarter, 2 quarters صارت minimum, 3rd quarter رجعت على الزيرو. So if I take screenshot of the string after 3 quarters of the period, right? The string becomes what? Straight. Any question about that, guys? And if I want to consider this, you might be asked about these things, guys. If I consider t over 8, t over 8 definitely will be in between 0 والquarter cycle. Okay, guys, if I want to find 5t over 8 again, here, this is the 0, the initial point. After 1/8, it becomes here. After another 1/8 here. another 1/8, it becomes here. This is 3t over 8. This is 4t over 8. This is 5t, and I will consider like this. Look here, how many eighths here, guys? 1, 1, 2, 3, 4, 5, and so on طبعا. Guys, this is called node. This is node. This is node. These are nodes, guys, and you will be asked to determine these nodes. These guys, these points are called antinode. Guys, this is what we observe. I think we observed that in the video. We observed that in the video, and I will see this pattern, right? I will see what this pattern. This is antinode. This is antinode. This is antinode also. Okay. We want to define something called resonance, guys. We want to define something called resonance. Here, guys, we have two things. طبعا this is just to understand the concept of the standing waves. This is called the driving pendulum. Driving pendulum. If I oscillate this driving pendulum, according that they are connected to the same string, all of them they will oscillate. All of them they will oscillate. But the one that has the maximum oscillation or maximum displacement, the one that has the same length as this ball, right? Or this driving pendulum. Okay. This is called resonance. If the frequency of the driving pendulum matches the frequency, listen to what will I say. If the frequency of driving pendulum matches the frequency of this pendulum, right, it will oscillate at maximum displacement. At maximum what? Displacement. I think most of you يمكن familiar بهذا الفيديو. طلعوا معي هون. Here we have a source of sound. Okay, source of sound. We will increase the frequency of this source of sound. Guys, the oscillation here of this glass is standing waves. As a result of the sound, right, the glass oscillates. If you see, this is by using high-speed camera. The glass oscillates. This is actually standing waves because the glass surface or bounds between 2 points. Look what will happen if I increase the frequency. I'm increasing the frequency now. called, guys, resonance. This is called what? Resonance. A resonance is taking place, guys, when, listen, when the frequency of the sound source matches one of the harmonic frequencies or natural frequency, it's called. So the glass of this or the glass will oscillate at its maximum possible displacement, so it might be broken. Is that clear? This is the experiment that we may carry out in order to investigate um, investigate the standing waves. Here, guys, if you look here, we have two fixed points. These are fixed points. Here, this is the weight. This weight, guys, produces what? A tension. Produces a needed tension for this frequency. You need a tension for this frequency. It can be measured easily. I have to measure this length, right? Oh, this is a generator, variable frequency generator. I have to change this frequency of the generator. I have to change it, right? Increase it or decrease it in order to match, or in order to reach the frequency that matches, listen, that matches one of the fundamental frequencies, or fundamental frequency or harmonic frequencies of the string. يعني here اتفقنا انه السترينج عندنا ايش n over 2 pi I think L square root T over mu. Okay, guys. So here I have different investigation that I may do. First of all, I may use the length. يعني I may vary the frequency with the length. يعني every time I have to move this bridge here, either right or left, in order to have different lengths between these fixed points. And we have to measure the frequency. We have to change the frequency until we get the fundamental frequency. Until we get what? The fundamental frequency. يعني each time I have to change the length. I have to change also the frequency of the vibrator, or a variable frequency vibrator. I have to change it until we got the first harmonic. Then I will have eventually this table, which is length versus what? Frequency. The other thing, I may change the tension. طبعا if I carry this out, if I carry the previous experiment, I have to keep the tension constant. The second thing that I may do, I may change the tension by keeping the length as it is and measuring the frequency when the first harmonic is observed. Okay, so I have here two investigations that might be carried out, either frequency versus length or frequency versus what? Tension. If I consider this frequency, I will consider 1 over length, guys, here, because it's inverse proportional, right? It's inverse proportional. I will get this graph. The gradient here of this graph is if I consider the frequency versus square root of tension, I will get also a straight line. The gradient here will be n over 2 pi L square root 1 over mu. next time إن شاء الله بنكمل الحصة ونكمل الأسئلة وبنشوف الأشياء هاي. أوكي، الله يعطيكم العافية.